Yes, good good evening, my dear friends. Welcome to the session once again. We still have 2 more minutes to go. We will wait for more learners to join in. We still have 2 minutes to go, and after that, we will continue. As you know, today the session is all about oceanography. Okay, oceanography, part 7. We have already covered geomorphology, climatology. Right now we will be covering oceanography. At the same time, since today is the first session in the year 2022 from the Unacademy platform and also from myself, I wish a very happy, prosperous and healthy new year to all of you. Okay, wish you all the best for all of your endeavors. We still have 1 more minute to go. We will wait for some more learners to join in. After that, we will continue. In 2 sessions, including today, that is today and tomorrow, we will be finishing this oceanography. The next chapter that I will be taking up will be biogeography. After that, it will be environmental geography. After that, we will go and see the human geography part. Clear? After that, gradually we will go again to Indian geography, thereby completing the entire syllabus, okay, of geography, especially for your UPSC, but also the information and the knowledge that you gain can be utilized in any of the competitive exam in India. Okay, so anyways, as we wait for more learners to join in, let me just share some good information from the Unacademy platform. Fortunately, unfortunately, today is the last day of getting 22% off. Okay, 22% off you will be getting from the month, from the date of 1st to 3rd of January. Fortunate in a sense, you are still eligible for 22% off. Unfortunate in a sense, today is the last day. Okay. Now, conquer your goal this year, that is the Resolve 2022. These are the main highlights. Plus combo, iconic combo. Subscription for 1 year, 2 year, 3 year. You see here, example, plus combo, you save around 13,000 rupees. Okay, you save around 26,000 rupees here for 2 year subscription. Okay, you will not be able to see because it is blocked by me, but you are getting for a iconic combo subscription for 2 years, you will be saving around 26,000 rupees. And for 3 years, this iconic combo, again, which you will not be able to see because it has been blocked by me, but you save around 34,000 rupees. Today is the last day. You can avail this 22% off. You can subscribe now. You can use my code, that is SUNEP10. Okay, now your prelims is right at the corner, not so long from now. Okay, your prelims is in the month of June. Okay, now taking that into consideration, from Unacademy platform, new batches are starting from 5th of January. Okay, after 2 days. Today is 3rd, from 5th of January. And if in your roadmap you are planning to sit for 2023, that is also not an issue. You can still join the course. There is Mission 2022, Mission 2023 also, Lakshya, Expedition for 2022 as well as for 2023. Clear? Now, one of the best part of this UPSC Civil Service Examination batches, that is the comprehensive batch course on GS, is you see here. You will get a set of around 20 general study books curated as per the latest trend of the UPSC. Okay, you will be able to catch all of this book if you go for a 1 year and above subscription. Clear? Now, one of the most important point is you see here. For GS, if you can catch all of this 20 GS book, you don't have to go and search for any topic from any section. Means you will not be wasting any time. Okay, one-stop solution. Therefore, you kindly subscribe and get hold of these 20 books, which is very, very important. Clear? Accomplish your mission with Unacademy. You see here, level up your UPSC preparation with this iconic subscription. Clear? You will get under this, the features are, you will get 1:1 live mentoring. Okay, personalized learning experience with the subject expert from the Unacademy platform. The second important feature is study planner and mains question and answer practice, which is the key, because we all know we have three different levels. One is the prelims, the other is the mains, and the other is the interview. Prelims is just for qualifying, its mark is not counted. Interview marks is less as compared to the mains. So your make or break moment comes in your mains. Therefore, you will get study planner and mains question and answer practice session. Customize your study plan with the bi-weekly review and strengthen your mains answer writing skills. Third, you will have this open house with the educator from the platform. Get to interact with our top educators, okay, with Unacademy open house. Clear? Also, finance should not stop you from achieving your goal. Keeping that in mind, in Unacademy platform, you have loans. The special feature of these loans are, it is absolutely 0% interest rate. There is no hidden charges, no processing fees, flexible tenure will be given to you, minimum paperwork. Clear? With this basic introduction, let us continue our discussion of today, that is ocean deposits. We have already covered, we have already started, and we have already covered some section regarding these manganese nodules. Okay, we are continuing from where we have left. So, if you are attending for the first time, I request you to kindly go and refer to my video in the YouTube itself. It is numbered by different part. Okay, part 1, part 2, part 3, part 4. So, accordingly, we are going from one topic to the other. The topic that we are discussing now comes under this ocean deposit. Under ocean deposit also we have already seen some of the important ocean deposit. Today we will start from this manganese nodules. Clear? Chalo, let us begin our discussion. Now you see, there is a deposit in the ocean by the name of this manganese nodules. Now, what is this manganese nodules? As a very quick recap or revision of what we have studied, the entire oceanic deposit we have already seen in the last class can be broadly classified into different, okay, lithogenous deposit, hydrogenous deposit, biogeneous deposit, cosmogeneous deposit that we have seen already. This comes under hydrogenous, which means from the oceanic water itself, it precipitates out. If it is a biogeneous deposit, which we will be looking after this, biogeneous deposits are the one where the ocean deposit origin is the marine organisms, be it plant or animal, having an organic content that is known as biogenic or biogeneous deposit. Whereas this hydrogenous deposit is from the ocean water itself, the sediments or the deposit precipitates out. Okay, why? Because we have already seen the properties of the ocean water. Okay, characteristics of the ocean water. We have seen in the ocean water, it is not a simple water you can see. There are certain dissolved material, suspended material. Okay, anyways, manganese nodules comes under hydrogenous deposit. Now, what is this manganese nodules? Very simple. A manganese nodules looks like a shape of a potato. In the picture which is in front of you, this is the real manganese nodules will look like this. And by the way, what are these? These are nothing but the deposit of manganese, iron, copper, cobalt or nickel. Simple as that. These manganese nodules which is in front of you is nothing but the deposit of this. Now, from where this material is coming? It is coming from the or precipitating out from the oceanic water itself. That's why it is known as a heterogeneous deposit. Now, in the ocean water, from where it is coming? Basically, it may come from, okay, there is no one single source. It may come from the elements originally brought down to the ocean by the rivers, from the land, from the rocks in the land. Okay, so it can be elements originally brought to the ocean by the rivers. It can be one source, and by the discharge of hydrothermal vent. Hydrothermal vent, let me give you one example which we have already seen, that is the MOR region, or similar activity, which means material, molten matter which comes from below. Okay, now in this hydrothermal vent, or you can say volcanic activity which is happening in the ocean floor, what happens is when molten matter comes out, it comes out with this material. Now when it comes out, it interacts. When it comes down, it interacts with the ocean water. When it interacts with the ocean water, it gets dissolved into it, and after some time, it may precipitate out under certain conditions. The conditions which we will discuss in a while. Now, it is one of the most conspicuous heterogeneous sediments that you will find. Okay, one of the most conspicuous heterogeneous sediments. Under the heterogeneous, lithogeneous, biogeneous, cosmogeneous. In the last session, we have seen the broad classifications of different ocean deposit. Under this heterogeneous deposit, manganese nodules are the most conspicuous. Now, how they are? First, they remain dissolved in the water. Now, it happens like this. You see here. Firstly, the first step is, just like under our climatology we have seen, for the precipitation, for the rainfall, what is the simple process of cloud formation and rainfall? The water vapor from the water surface goes up, okay, in the form of vapor. It condenses after reaching its dew point. Now, for this condensation of water vapor in the water droplet, it requires a nuclei. Without the nuclei, it undergoes the supersaturation stage and it does not condense. That we have seen. It requires a nucleus. Similar, very, very similar to that, this heterogeneous these deposits, these materials or minerals, I can say, or elements, I can say, they, in order to form the size of this, okay, it requires certain kind of nuclei. Now, these materials or elements is already present in the ocean water. In order to precipitate out, it required nucleus. The nucleus is provided, okay, by the hard object. Now, from where this hard object will come? This hard object can be the tooth or the bones of the shark, okay, so on and so forth, hard object. Now, it acts as a nuclei. Around this nuclei, okay, these elements or the material which is already there in the ocean water will start to precipitate around this one. The process of precipitation and the time taken for the aggregation is very, very slow. You see here. Here in this diagram, you please come. The white color that you will find here, it is the nucleus. It is the hard object. Around this nucleus, year after year, it takes a very, very long time in order to come to this size. Okay. Now, say for example, the basic two condition, that is the availability of the hard object as a nuclei for aggregation. Second, the presence of this material or the elements during its process. Say for example, it has started the process of aggregation around this. Okay. Now, it requires certain kind of stable environment and also at the same time away from the sediments. During the process of aggregation, okay, in the initial process, if there is lot of sediments, then further aggression will not take place. Why? Because it will be buried under the sediments. So further aggression will not take place. Therefore, in a place where you have lot of sediments which comes into the ocean water, such kind of manganese nodules will be absent. Therefore, you go and see. We have already seen the ocean bottom topography of Atlantic Ocean, Pacific Ocean, Indian Ocean, okay, Arctic Ocean. Now, in the Atlantic Ocean, you don't have this trench area. That was one of the main characteristics. In Atlantic Ocean, you only have this exception, that is the Puerto Rico trench region. In the Pacific Ocean, you have trenches on both the sides. In Pacific Ocean, which we have seen. Therefore, in Atlantic Ocean, what will happen is, from the land area, whatever the sediments will be coming will reach the ocean floor. Why? Because they don't have a trench area. On the other hand, in the Pacific Ocean region, what will happen? Any sediments which are coming from the land area, because of the presence of a trench in both the side of Pacific region, these land-based sediments will be get lost in the trenches. Therefore, what you can come into a conclusion, in the Atlantic Ocean region, the presence or the formation of these manganese nodules is not conducive. Therefore, it is very rare in the Atlantic Ocean, whereas you will find in the Pacific Ocean. And why is this so? I have already explained to you that the aggregation process is very, very slow. Therefore, in a place where you have lot of sediments, such kind of full-blown manganese nodules will not be formed. Even though the initial condition of the nucleus and the presence of this material in the water is there, and let us assume that the initial process of aggregation has been started, even then the full-blown shape of these manganese nodules will not be present. Clear? I hope that is clear. Any doubt, any one of you? See, the only mode of interaction between us will be the live chat box below. So you can interrupt me at any time if you are not able to follow any portion. Okay, for your information, let me tell you, I have a special class and plus course in Unacademy platform where we have better tools of communication, where I have better tools, and also even the learner has facilities like raise your hand or the message box below where you can type very efficiently, where I can be able to interact with you clearly. From tomorrow at 7:30 p.m. I am starting one new course in special session that is completely free of cost. It is under Unacademy platform. It is absolutely free. I am starting one course that is Geography of India through maps. There we will see all the important aspects related to map of India. So you can come and join me there also. Okay, I am starting from tomorrow. I am going to complete the entire syllabus of Indian geography through map. Clear? See, these are the places where you will get these manganese nodules. These are the distribution. You come and see. You see here. This is North America, South America, Africa, Europe. This is Atlantic Ocean. Now, you see here, this color represents the distribution of the copal crust. This is the occurrence of a manganese nodules. Now, in all of this region, you will find manganese nodules. But here are you able to find any? No. Which means in Atlantic Ocean, because of the presence or absence, you can say, of the trench area. But in Atlantic Ocean, you see, here you have trench. Therefore, condition is suitable for the occurrence of this kind of manganese nodules in the Pacific Ocean region. Clear? Let us quickly go ahead. The next category of oceanic deposit is this biogeneous deposits. Okay, now biogeneous deposit, as you know, and in the last session also we have already mentioned, that is I think on the 22nd of December 2021 we have already discussed. Biogeneous deposits, in a sense, the source of the deposits are nothing but the organisms, marine organisms. Clear? It can be plant or animal, or you can say the organic content, that is known as a biogeneous deposit. This biogeneous deposit which you have in the ocean can be broadly classified into two regions, that is in the continental margin, shallow continental margin. Other one is in the deep ocean region. In the shallow continental margin, the deposits are mostly of terragenous. Terragenous is from the land area. Along with this, you have these marine organisms, that is the skeleton fragments, okay, of bendos, that is the bottom dwelling. It may be from the mangrove area, it can be from the coral reef also, okay. But one important point is, in the shallow continental margin, the biogeneous deposit will be more of this terragenous, that is land based. Why? Because it is near to the land. Now, in the deep ocean, okay, in the deep ocean bottom, the biogeneous deposit can be either ooze or red clay. Ooze, in a sense, it is a tiny skeleton of microorganism that is known as ooze. Ooze has two broad categories, that is calcareous ooze and siliceous ooze, which we will be discussing in detail later. The other type in deep ocean, the oceanic deposit belonging to this biogeneous class is the red clay, which are continental in nature, that is the source. Ooze plus red clay combine together to call it as a pelagic deposit. Keep this in mind. Pelagic deposit is nothing but the combination of ooze and red clay is referred or termed as pelagic deposit. Clear? Now, you see here. Let us first go and see what is this ooze. Ooze, they are the remains. You see here, it is the tiny skeletons of microorganisms. What is these microorganisms? This may be a plankton, that is the wanderer. It can be a zooplankton, phytoplankton. Now, unicellular marine plant, okay, unicellular marine plant, example, diadem. Source region can be this. Remember, ooze is the tiny skeleton of microorganism. Microorganism can be plant or animal. Now, one of the source is the unicellular marine plant, that is the diadem. And since it is a plant, by name itself it is very clear. A plant prepares its own food by the process of photosynthesis. And what is one of the very important condition of photosynthesis? The sun insolation. Therefore, these diadems who can prepare their own food in the ocean environment, okay, belonging to a plant kingdom, you will find this only in the photic region only. If there is no sunlight, where is the question of photosynthesis? Clear? Now, this is one of the source. In our discussion of marine resources, all of this is very important. So kindly keep this in mind. Remember here itself, you see here, unicellular marine plant is known as diadems. The ooze, since it is a tiny skeleton of microorganisms, microorganisms can be an animal also. Example, these are known as radiolarites. Now, there are numerous planktons, that is the wanderers. It may be a phytoplankton or it may be a zooplankton. There are numerous, but the name that we are taking here, these are one of the most important. Therefore, it is required from your side to remember this name. Okay, you can add more, but whatever I am discussing here, it is a compulsory. Okay, now which means it is the minimum. Okay, floating mollusk, example, pteropod can be another. Eggs and larvae can be. See, all of this can be a source for this ooze. Why? Because ooze is the tiny skeletons of microorganism. Okay, all of this, they don't have their own locomotion. That's why they are known as a wanderer. They just float. Now, when all of these organisms, be it diadem, be it radiolarite, be it pteropod, they will die. When they die, they will sink. When after sinking, they accumulate. The accumulation of all of this resulting in the formation of this ooze, and which is nothing but the biogeneous deposit. The texture, in order to have a feel about what will be the nature or the characteristics of this ooze, when you dry, when dry, they are like flour in the texture. If sediment consists, remember, very important, if the sediment consists more than 30% of fine biogeneous sediments by weight, it is called ooze. So do you know the technical definition now about this ooze? So, see, it may not be completely biogeneous. There may be certain kind of impurities. But what is the criteria? What is the condition? The condition is very simple. That is, if sediment consists, sediments of what? Sediments of all of this. When they die, they will sink, they will form these sediments. And when this sediment consists more than 30% of fine biogeneous sediments, by weight, it is known as ooze. Keep this in mind. This is a technical definition. In your exam, there may be a question regarding define ooze. Then you will have to give this definition. Clear? Now, as I told you just now, ooze can be of two forms. That is, calcareous ooze or siliceous ooze, based on their distribution, where they are found. We will see one by one. Before we see the distribution of where they are found, let us see some important characteristics of this classification of ooze by the calcareous and siliceous ooze. Now, the supply of organisms are more in the higher latitude and along the equator. Now, the dissolving capabilities of water through which the organism falls. Water, if readily dissolves, they will not survive the long settling time. Which means, forget about calcareous and siliceous if we are just taking the general term of a ooze. If, readily dissolves, they will not survive the long settling time. Another factor, rate of dilution. Biogenic ooze seldom form on continental margins because of dilution by terragenous sediments. You see here, what is continental margin? Continental shelf and continental slope are called as continental margin. Now you see here, continental shelf and continental slope is adjoining to the land area. Therefore, from the land area, the river brings in the sediments. Now, rate of dilution, in a sense, these sediments will come and interact with all of this ooze, which is the tiny skeleton remains or of these microorganisms. Now, they will be diluted, mixed. Therefore, substantial amount or the presence or the formation of such a ooze may itself be difficult. That is one of the factors. Another is the dissolving capability of the water. Water has got certain characteristics, the oceanic water, acidity. Depending on this, certain materials are getting dissolved. Now we will see that in detail. Based on the dissolving characteristics, or the capacity of the dissolving capacity of the water. Let me just tell you now itself, the dissolving capacity of the water may change as per the acidity of the oceanic water itself. Now, the acidity of the oceanic water also can be determined by the temperature. Now, that is one. On the other hand, the material, if it is, the material of the deposit is also another factor of whether that particular material will dissolve in the water or not. So there are many factors. So depending on whether certain oceanic deposit will be dissolved or not at what particular depth, the ooze is broadly classified into two categories. Those are calcareous ooze and the siliceous ooze. Under this calcareous ooze, the first category is Globigerina ooze. They are one of the most widely spread. They are formed, means die down, sink, accumulate of what? One cell animal known as foraminifera. They will be found both in the temperate as well as in the tropical waters. Few distinctive species live in very cold water. They are milky white away from the coast, bluish gray near the coast. You see here, this calcareous ooze, which is the Globigerina, is having 64.47 percentage of calcium. Okay, you don't have to remember this numerical figure, but just to give you an idea, which means this calcareous ooze, as the name suggests, below is rich in this calcium. Only 1.64% is siliceous, and other material is a fine washing. They are a very important characteristics of Atlantic Ocean, Western Indian Ocean, parts of Southwest and Southeast Pacific. Pteropod, another type of calcareous ooze. All of these are calcareous ooze. You see here, 80% calcium carbonate. Okay, this pteropod ooze is nothing but the aragonite shell of pteropod. They are nothing, these pteropods are nothing but the small graceful swimming snails. They will found away from the continent on the reaches and the warm water. Example, Azore Island, Antilles, where you will find this Azore. Kindly locate on your atlas. Antilles, kindly locate in your atlas. These are very, very important island. Okay, and one assignment let me give you, whether it is a volcanic island or not. Okay, anyway, Canary Island and reaches in the Indian Ocean. On these regions you will find this type of a ooze. Okay, now Coccolithophore ooze, that is the single cell plant, means this also comes under this calcareous ooze, that is the third subcategory. Now you see here, in all of these ooze, be it a pteropod, Globigerina or Coccolithophores, the content of calcium carbonate is high. We have just seen. In pteropod it is around 80% calcium carbonate. It is high. Now you see here, calcium carbonate dissolve in cooler water, but not in warm water. Okay, calcium carbonate, remember this. Only kindly pay attention. This particular ooze, that is the calcareous ooze, one is Globigerina. It is also having a calcium content of more than 60%. The second one is the pteropod, nothing but the small graceful swimming snail. Calcium carbonate is more than 80%. Now you see here, all of these calcareous ooze, okay, are rich in calcium carbonate. Now the important characteristics is calcium carbonate dissolves in cooler water, but not in warm water. Okay, the point which I have just mentioned to you, the acidity, okay, can also be determined by the temperature of the water. That can be one factor. Now, and also the material of the sediments itself may determine the dissolving capacity. Now, the material is calcium carbonate. Okay, now it dissolves in cooler water but not in the warm water. Therefore, since this calcareous ooze is rich in calcium carbonate, that is one point. Another point is, we know from the surface of the water, if I go down below, means the more depth I go below, the lower the temperature. The water is very cold below, warmer on the surface. Therefore, you will find this calcareous ooze near the surface of the water and not beyond certain depth. Okay, that particular depth up to which you will find this calcareous ooze, beyond which you will not find this calcareous ooze. Why? Because it will be already dissolved. That particular line is known as calcium carbonate compensation depth and it is around 4 to 5 kilometers from the surface of the water. Dissolves at all the depth in high latitude, you see here again. Why? Because in the higher latitude, even on the surface of the water, the temperature of the water is very cold. Therefore, the calcium carbonate itself will be dissolved. Why? Because it dissolves in the cooler water. and in deep waters of temperate and tropical latitude it will be dissolved. Yes, in temperate and tropical latitude it will be found near the surface, but beyond that, even in the tropical region, the moment I go down, temperature reduces, the temperature of the water decreases. Therefore, in the deeper water it will be absent. Clear? That is one, like this. Say for example, if I just give you a graphical representation, it will be like this. This can be a calcium carbonate compensation depth, which means, say for example, this is ocean floor. Okay, just consider this to be an ocean floor. Only up to this extent you will have this calcareous ooze. Beyond this depth you will not have this calcareous ooze. Even if you have calcareous ooze, it will be dissolved. Therefore, the ooze is classified or divided into two, that is calcareous ooze rich in calcium carbonate, and the other is siliceous ooze. We have just seen what is calcareous ooze. Let us go and see the siliceous ooze. Below this calcium carbonate compensation depth, which I have just explained to you, this siliceous ooze will predominate. From the surface of the water, if you go below, beyond this carbonate compensation depth, you will have this siliceous ooze, which will predominate. It is not found much in the northern waters because of heavy dilution by terragenous sediment. Why? See, you just consider the globe of the world. You draw the equator, okay, you see the northern hemisphere, you see the southern hemisphere. In the northern hemisphere you have more land area, in the southern hemisphere you have less land area. Therefore, terragenous sediments means land-based sediments. Therefore, in the northern hemisphere we have just seen some of the factors of formation of this ooze. We have seen, right, the rate of dilution, if you remember this point, rate of dilution. Therefore, in the northern hemisphere, you wouldn't have much, not found much in the northern waters, means in the northern hemisphere, because of heavy dilution by the terragenous. Okay, eye cover inhibits biological productivity also. And what is ooze? Ooze is nothing. Charles McCormick. Happy New Year. So, see, the cooler, less biological productivity, resulting in less biological activity, which means what is ooze? It is the skeleton remains of microorganism. Therefore, in this region also you will not have much of this deposit. Diodome, that is one, that is single cell plant, band across Antarctica, North Pacific, light and nutrients. Radiolarine, these are the single cell animal you will find in warm equatorial waters, Central America and Pacific. Distribution will look like this. Kindly look at the diagram or world map which is in front of you. You see here, pelagic deposit, okay, siliceous ooze. This is radiolarine, diadome. This is radiolarine. This is calcareous ooze. This one. Whatever we have been discussing just now, you just try to correlate with what you see in front of you, the world map. Okay, chalo, let us quickly go ahead. Red clay, most widely spread pelagic deposits in deep ocean bottom that holds little marine life. You see here, most widely spread pelagic deposit. And what is pelagic deposit? We have just seen now, ooze plus the red clay. Now you see here, these are the most widely spread pelagic deposit in deep ocean bottom that holds little marine life. Yes, you will have marine organisms on the ocean floor, okay, ocean bottom, but the ratio or the number of organisms is much less as compared to other layers. Okay, so in this red clay will be most widely found. Example, North Pacific, middle of South Pacific, Eastern Indian Ocean, deeper basin of Atlantic. In all of this region you will find clay minerals. These red clay are clay minerals. These are wind-blown volcanic ash. Other source can be submarine volcanic eruption. Another source can be the shark and the whales remains. What is the composition of this red clay? Composition will be, it will have calcium, which is only around 6%. It will have this siliceous organism, which is around 2%. Minerals will be around 5%. Most important is the fine washing, which will be around 85%. Let me tell you once again, you are not required to remember all these numerical figure in percentage term, but kindly remember the comparative composition of calcium, siliceous and the fine washing. Under our siliceous ooze, calcareous ooze, we have seen the there also you don't need to remember the numerical percentage, but at least you need to know the comparative composition of siliceous, of calcium, of siliceous, and also of silica, and also of the fine washing. Clear? They are also known as brown clay or the brown mud. Cosmogeneous deposit. What is this cosmogeneous deposit? Nothing. In your screen in front of you, under this cosmogeneous deposit badge, it is empty. It is completely black. What is the meaning of this? Which means it is absent? No. It is also there. We have already seen cosmogeneous is another category. In this cosmogeneous deposit, we have already seen that meteorites hitting the or reaching the Earth's surface, falling down on the water body, they results into this cosmogeneous deposit. Clear? So anyways, today is the first session in this month or in this year, I can say. So wishing you once again Happy New Year, and we will continue. Tomorrow also I will take one session about this oceanography, and after that we will start a new chapter, that is the biogeography. Okay. We'll end the session here today. This month also I will conduct around 15 session. Okay, 15 session. Each session is consist of 40 minutes. Okay, 40 minutes. The timing is, as you know, it is from 9 to 9:40 p.m. always. Clear? We'll end the session here today. Thank you all for your patience and cooperation. We will meet again tomorrow at the same time. Bye-bye and take care.